それではまずはじめに、クラウドとマイクロサービスによる音声操作の新時代、Amazon エコー&アレクサと題しまして、シニアエヴァンジェリスト AWS、Amit ジョットワニ様よりご講演いただけます。Please welcome Amit Jotwani。
Konnichiwa, Tokyo. Thank you for coming. This is my first visit to Tokyo, and I'm thrilled to be at AWS Summit today. Now, I'm not sure how many of you have had a chance to meet Alexa. So today, we're going to do something that has quite possibly never been done in Japan before. We are all going to say hello to Alexa. Are you guys ready? All right, so on a count of 3, I would like all of you to say, hello, Alexa. 3, 2, 1. Hello, Alexa.
Hello, Tokyo. Konnichiwa. This looks like a fun audience, Amit. I am very excited. Let's get started.
It sure looks like a fun audience. Now let's get started here. My name is Amit Jotwani, and I'm a senior evangelist on Alexa Voice Service. And I'm really thrilled to talk with you today about how to build voice experiences with Alexa. Now, before we get started, here's a quick summary of what you can expect to get out of this session. First and foremost, we'll be talking about why voice is important and what it means for the future. Secondly, we'll get into what Amazon Echo is and what the Alexa platform is. And then we'll get into the introduction to the Alexa's developer platform and what you all as developers can do to contribute and build on with the Alexa ecosystem. And then finally, I'll leave you with creating your first Alexa skill. That's right, we'll be doing some live coding here. Are you guys excited? All right, so let's get started. I want to start off with this quote that I found some time back, and I thought this was really profound. It says, the age of touch could soon come to an end. That touch is no longer the primary user interface. Now, if you actually think about that for a minute, and let's roll back 10 years to 2006. If I told you back in 2006 that in 10 years, keyboard and mouse would no longer be the primary user interface, you'd probably laugh in my face, right? But 10 years fast forward to today, keyboard and mouse is no longer the primary interface. It's touchscreen, right? The mobile devices and touchscreens have completely revolutionized pretty much everything that we do today. But having said that, there are still certain things that mobile devices are just not designed for. And one of the best examples for that is how we use our mobile devices to control our smart home and all these IoT devices that are coming out. They're just not good user experience. Now, one of my favorite examples to illustrate how bad this UX is how I have to operate my light switch at home. So let me illustrate you how this actually works at home. I walk into my room, I get my phone out, I unlock the phone, I find the app for my light, and I fiddle with it, trying to figure out which bulb it is that I want to turn on, and then I tap on it, I wait a few seconds, and then if I have my luck, the light will turn on. Now think about this. This is really bad experience. At this point, my wife once said, you might as well have just flicked the switch on the wall. It might have been just easier for me to do that, right? And we think that we are at that cusp again, that all these experiences can become easier with voice. We believe voice is the future, and it will completely change the way users interact with technology. Why do I need an app to tell my home speaker system to play some music? Why do we need a smartphone to put things on our shopping list when we have the power of voice? You can imagine a world where we are making dinner reservations while driving to a restaurant. We can control our garage doors while still driving and not using the phone. You can also imagine voice interfaces to be in your kitchen. In fact, kitchens make the best use case for voice-driven technology. You're cooking, you just want to set a quick timer. You don't have to take your phone out. All you have to do is just talk, and the timer is set. And similarly, the smart home, obviously, you can connect all of these IoT devices, and you can control all of them using voice. And voice is really important, and that's why Amazon believes that that's going to be the future, because voice is the most natural user interface ever created. We all have been doing this for a while now, and we are pretty good at it. So why not use that? You just talk. There is nothing that you need to do. All you do is talk, and your thing gets done. And the final one, I think, is critical. How often do you wake up in the morning, and you take a phone out, and you want to check weather, but 20 minutes later, you're still on Facebook, right? It's really distracting. So with voice, you get a quick sign in and sign out kind of experience for exactly the thing that you were looking to do without any distractions. So let me give you a quick demo of Echo.
Alexa, tell me the news.
NASA unveiled amazing new images of Pluto today, unveiling a surprisingly...
Alexa, how far is Pluto from Earth?
4.67 billion miles.
Alexa, play my road trip playlist.
He's going the distance. He's going for speed.
Pretty cool, right? That is Amazon Echo, which is really a hands-free speaker with far-field voice recognition built into it. We released it back in 2014, and our customers have absolutely loved it. We've received over 36,000 reviews on Amazon.com with 4.5 stars. It turns out the media loves it too. But let's take a quick look at what the Echo really is from the insides. The Echo, like I said, is a hands-free voice recognition system. And what it is really designed to do is, it has the capability to listen to the speaker from across the room. It is listening for the wake word Alexa. So as soon as you say the word Alexa, it starts to listen, and you know that it's listening because the LED ring on the top starts to, it turns blue. That's when you know that Alexa is listening at this point. It also has a mute button on the top, so if you do not want Alexa to be listening, you can turn it you can turn the mute button on, and it turns the LED ring into red. And this is really important to us. At Amazon, we value privacy of our customers deeply. And doing things like this and thinking of all these things that will make customers even more secure about their privacy and their data is really important to us. And things like that is built into the Echo. So the way it works is you just use the wake word Alexa, and then you can say, Alexa, play some music. Alexa, what's the weather? And now we are also allowing other developers to build more capabilities for it. And we'll get into this in just a bit. So the Echo was actually just the first endpoint or the first device that has the capability to respond to Alexa-related commands. We have since released another device called the Echo Dot, which is really a mini version of the Echo. It has a smaller speaker, but it has the same far-field voice recognition capabilities that the Echo has. And then we also have the Amazon Tap, which is a portable Wi-Fi-enabled speaker system with a push-to-talk implementation, which means that unlike the Echo, it's not always listening. You push the button, the microphone button on it, and that's when it's listening. At that point, it has the same capabilities that the Echo or the Echo Dot have. And then a few weeks back, we enabled Alexa to be on the Fire TV as well. So if you have a second-generation Fire TV, you can push and press the microphone button on the remote, and you get the same capabilities that you would with an Amazon Tap, for instance. And all of these devices are powered by the same technology, and we'll talk about that, which we called Alexa. Now, Alexa can do your smartphone. Going back to the previous example, with Alexa, now I don't need to fiddle around with apps. All I'd say is, Alexa, turn the lights on, and boom, the lights are on. Now, we talked about the Echo. Now, let's talk about the beauty and the brains behind all these devices, which we call Alexa. And Alexa is really the cloud service platform that handles all of this voice recognition in the cloud for us. All of the speech recognition, the natural language understanding, all the machine learning, and all the skills that Alexa has are all sitting in the cloud. And since it's all sitting in the cloud, Alexa gets smarter every day. It is learning every day. It is learning and improving based on the patterns of your specific usage. So the more you use it, the more smarter Alexa gets. And since it's all sitting in the cloud, any new features and any new updates are just pushed out automatically. There's nothing you have to install. There's no wait whatsoever. Now, there's so many possibilities when it comes to Alexa, and we are really excited about it. But we know that we cannot build everything on our own. And that's why we want to open up the developer platform. We want to build a true developer ecosystem where the focus is on voice and voice design. And to do that, we have opened up the Alexa ecosystem. And we really have two kinds of SDKs that we have released for the developers. The first is what we call the Ask, which is the Alexa Skills Kit, which is really a collection of APIs that you as developers can use today to build skills. And by skills, we mean you can add more capabilities to what Alexa can do. So when we first launched it, Alexa only had 13 capabilities. But we opened up the developer platform, and now we have over 1,000 skills that Alexa can perform. And you as developers can just start doing that today with Alexa Skills Kit. And the other side of the ecosystem is what we call AVS, the Alexa Voice Service. And this is where if you have a device that has a microphone, a speaker, and an internet connection, you can actually integrate Alexa into your devices. So if you are a device maker, think microwaves, think alarm clocks, think even an enthusiast like a Raspberry Pi. If you want Alexa voice integration into your devices or your apps, you can do that today with Alexa Voice Service. Let's look at AVS first in a bit more detail. Now, what's happening here in the diagram here is that you have this device, you capture the audio on this device, and then you transfer this audio to Alexa Voice Service, where everything ASR, NLU is handled for you. The response is sent back to your device, and all your device is really doing is just playing the audio back. AVS actually serves the vision that Amazon has with Alexa everywhere. If you look at this illustration, we have all these different kinds of devices. Not all of these devices are good candidates for voice integration. Like a light bulb may not have a microphone and a speaker, but it still would be connected somehow to the Alexa ecosystem, so it could still be controlled by one of these other devices. So in this illustration, the devices with a blue bar are good candidates for Alexa integration. So I could be in my car driving around, and I could still control my light bulbs. Or I could be talking to the Echo and have the ability to control my wireless speakers. And this is what the Alexa platform looks like. We have all these devices which have Alexa enabled on them. And as we go along, build the ecosystem, we'll have more of these devices that will have Alexa enabled on them. And all of these devices are talking to the same AVS service. And within AVS, we have all these different components. We have the first thing is what we call the ASR, which is automatic speech recognition, which is actually really straightforward. Even your smartphones can do that today. And what ASR really does is it takes some audio and converts them into discrete English words. That's all ASR is. The hard part, though, is the NLU, which is the natural language understanding, which is to take some discrete English words and try to understand what the user may have meant with it. What was the intent behind that spoken utterance? And that's what NLU does. The third piece is the TTS, which is the text-to-speech service, which is to take certain text and then convert it back into speech so it can be played back on the device that it came from. And then, like I said, we have all the skills also living in the cloud. And all of this with the learning that happens because Alexa is living in the cloud and is powered by AWS in the background. Now let's take a quick look at how this actually flows. So we just saw the demo of Echo. Let's see what actually happens when you say something to an Echo. So when you say the wake word, Alexa, there's a wake word engine that's actually sitting on the device. It detects that the Alexa wake word was said. It converts it. It captures the audio. And then it sends it to the speech platform. And the speech platform really is acting like an orchestrator or a router of sorts, just routing all these requests between all these different components. So when the speech platform gets a request, it sends it to the ASR, where the result is recognized and the recognition result is sent back to the speech platform. The speech platform takes this recognition result and sends it to NLU, which tries to understand what was actually the intent behind it. And it sends back what we call an intent, which in other words is just what action did the user expect out of this utterance. And that intent is sent back to the speech platform. The speech platform knows what skill it needs to route this intent to. Because when you're creating the skill, and we will see that, when you create the skill, you specify what intents and what invocation names you are specifying for your skills. So it sends it to the appropriate skill, which could be one of the built-in skills like weather information, or it could be a custom skill that you as a developer have built. It knows that, it gets the response back with what we call a speak directive. And directives are really just instructions from the Alexa voice service back to the device to do something. And in this case, the instruction is speak it back. So it takes that along with the content that needs to be spoken back, and one final time it sends it to the TTS, where this text is now converted back into speech, and that speech is then reverted back to the speech platform, which throws it back to the Echo, and the Echo handles the playing back of that audio. And all of this, mind you, happens in fractions of a second. And this is really important because when you're having that conversation with Alexa, it needs to have the absolute minimal latency, especially when you're having those multi-turn interactions with it. For instance, if you ask Alexa, Alexa set a timer, she will come back and say, how much time? And then you will say 10 minutes. And this kind of interaction really needs to be fast in order to be convenient and seem natural. And all of this happens because it's really, really quick. Now here are a few Alexa-enabled devices that some of them are already out there, and some of them will be released. The first one on the left is the Tribi, which is a kitchen speaker system. It's got a magnet, it sticks to your fridge. You can make and receive phone calls with it, you can send and receive messages, but it's also got Alexa built into it. And it's got the same kind of wake word engine to it. So all you have to do is Alexa, and this device will be ready to accept those requests. So it works exactly the same way you would expect the Echo to. The second one is a smartwatch. This will be the first smartwatch with Alexa built into it. So again, you would be able to talk to it. This would be a push-to-talk implementation, so you would tap on your watch, and now it's ready to listen, and you would be able to have the same interactions. This was launched a couple of weeks ago, or about a month ago, on Indiegogo, and they've already surpassed 200% of their target. They should be releasing it in a couple of months now. And then finally, we love developers. So we thought it would be really awesome if we can actually release a Raspberry Pi version of Alexa. So if you are a developer, you are an enthusiast into hardware, and you want to build your own Alexa, you can actually do that today with a Raspberry Pi, a speaker, and a microphone, and Alexa voice service. And if you're really interested, I would encourage you to go to github.com/amzn and just look up the Raspberry Pi project. We have very detailed instructions, and we list all the hardware that you actually need and step-by-step instructions how to do that. We're also seeing some apps which have Alexa built into them. The first one is Roger. That's an iOS and Android app. What it really is a walkie-talkie of sorts. So you can add your friends and you can send them audio messages. But these guys got really clever, and they added Alexa as a friend, which she really is, to be fair. They added that as a friend, and now they can have those same conversations with Alexa which you would normally have with a device. And the other one is Lexi, which is really a dedicated Alexa app. So if you as a developer are just looking for some quick ways to test out a skill that you have been building and you don't have access to a hardware device, you can actually test that on one of these apps. Now let's switch gears a little bit and talk a bit about skills. Skills, like I said, are capabilities that Alexa has. And there are really two kinds of skills that you can build. There are built-in skills, which Alexa already comes with, and there are some custom skills that you can build. So now you can have an Uber skill which says, ask Uber to get me a ride, or you can ask Fitbit how many steps you've taken. And all these apps have been possible because of the Alexa Skills Kit. And the way you build those apps is by using this collection of APIs that we call the Alexa Skills Kit. And there are really two kinds of skills that you can create. One is what you can take an existing service and create just a voice layer for it. So an Uber or a Domino's or a Fitbit would be a good example of that. The other is, which will probably be a lot of you, would be creating this skill from the absolute scratch. You're building this completely new voice-powered skill for your specific use case. And both of these use cases, you can do them in a matter of hours. Now, Alexa is deeply integrated with AWS Lambda, which is really a great way to get started with Alexa Skills Kit. You don't have to worry about any of the management of the servers. All you really do is put up your code on the cloud somewhere, which gets triggered when an event occurs. And that event, in this case, would be your skill getting called by the user. So when the user calls the skill, this Lambda function gets triggered, and it knows what needs to be done based on that. So what we'll do here is we will actually create a skill using AWS Lambda and API Gateway. But before we get into that, let's quickly go over what exactly is a skill and how it's set up. So the Alexa skills are really set up on the serverless paradigm, which really means that when you create a skill, what you're doing is you're creating a microservice of sorts that's accessible independently as an endpoint. In fact, when you create a skill, you don't push anything to any of these devices. The user just gets up in the morning and that skill is available. That's really how simple it is. Excuse me. And the Alexa skills really have two parts. The first, or as you would expect with even a mobile device development, the first is what we call the configuration data or the front end. Now this is where you specify the interaction model, which simply put what means that any phrases or words that you expect your users might say, you collect them all together into this interaction model. You also specify any variables or arguments that your user might expect, that you might expect your users to be saying. And all of this is then matched up to the intents. So when user says a certain phrase, what needs to be done is what we define as an interaction model. And the second part is the backend, the hosted service. This is where your code lives. This is what Alexa Skills Kit will call once it knows that your skill has been called. So we are just minutes away from live code. let's quickly look at how this will actually work. So the first thing is your user makes a request. The audio stream is sent to Alexa, where all of the ASR, NLU magic that we just saw happens. Alexa will send this to our service, which will be sitting on AWS Lambda. We will call an API, which will be sitting on API, Amazon API gateway. The API will return some information back to the Lambda. Lambda will push that back to Alexa. It'll be converted back into audio. And then it'll be played back as an audio response on the echo. But if you look at down below, what also happens is that it'll also send a card response to the Amazon Alexa app, which is available for iOS, Android, and it's also available as a web wrapper on alexa.amazon.com. The Alexa app is how you would enable or disable skills. The Alexa app is also how you manage your connected devices. And when you ask Alexa to do something, it'll send a card response in addition to the audio to this Alexa app. So for instance, if you ask Alexa what's the weather, she will tell you what the weather is, but she will also send a small card which may contain more information about the weather for the next few days, and that will be available on the Alexa app on your mobile device. So in this case also, it'll send back a graphical response back to the user. All right, it's time to write some code. You guys ready? All right, let's jump in. Let me set my resolution right. All right, so one of the first things we will do is go to developer.amazon.com. Can you guys see this okay? Okay. And I'm going to sign in to this account. And let's go ahead and sign in. Has anyone here played around with a skill? Anyone created a skill just as a hobby? Yay, one hand. Yay, two. Awesome. Okay, so I'm going to click on Alexa. And this is really the first part that we are doing. We are creating the interaction model here. Now, there are two things that you can do, Alexa Skills Kit and the voice service. We will be creating a skill today, so I'm going to get it. And then say add a new skill. And we will call our skill JAWS, Japan AWS. How's that? And the invocation name is what you want the users to be saying. So in our case, it'll be Alexa, ask JAWS for XYZ information. So we'll call it JAWS. Click next here. And I have some snippets that I'm going to dump here, and I'll go over these. So the first box is where we are specifying the intent schema. And this is really just a JSON blob where I'm specifying the intents. In our case, we have one action item. The user might ask for description of, well, I should back up and tell you what exactly I'm doing. That'll be helpful, right? So what we are going to do with this skill is we have a user who is new to AWS. And we want to build a skill that users can get more information about certain services that AWS has. So the way it'll work is our user will say, Alexa, ask JAWS what is Lambda. And then Alexa will respond back with what Lambda is. Or you could say, Alexa, ask JAWS about EC2. And it'll come back and give you a response about what that service is. So in this case, we will have just one action. We'll just have one function which will return the information around this. So we're going to call it service description intent. And then we have slots. And slots are really variables or arguments or parameters, depending on what you want to call them. And these are things that we expect that users might include in the utterance that they might say. So in our case, it'll be when you say, ask JAWS about Lambda, the word Lambda is really the slot. or the argument that the customer is actually passing to us, and we need to grab that. So the way we grab that is through slots. And we've specified one slot. It's called name. Let me just increase this a little bit. Is this better? So the name of the slot is service name, and the type is list of services. And then I'm going to specify what list of services are. So I'm going to add a slot, and I'm going to call it list of services. And then I am going to, these are the things that our customers might ask for. So all we are doing here is really helping Alexa that these are the things that our users might say. So please include that in the model. I'm going to click OK here. And then finally, we are specifying some sample utterances, which are really some phrases that we expect our users might say while activating this. So I'm going to, now if you look at this, let me minimize this so we can get this on the same screen. The service description intent is the intent that we specified. And what we are doing here is we are matching these intents with some phrases. Now, this is really important when you design a voice interaction. Not everyone will actually invocate the skill the exact same way. Some people might say, tell me about Lambda. Some people might say, what is Lambda? Some people might say, what do you use Lambda for? So when you're designing the voice interactions, you want to make sure that you are actually accommodating as many of these use cases as possible. And the sample utterance is really one way that you can do that. So we'll just keep it to that. Click next here. And now we have to specify the endpoint. And the endpoint is where your code will be residing. And there are two ways that you can do this. You can put this on an HTTPS endpoint that's accessible on the internet anywhere. The only thing you have to make sure that it's an HTTPS endpoint with an SSL certificate. The easier way to do that is through Lambda, which is what we'll be doing today. So now we need to step over to AWS console and create a Lambda function real quick that we can connect to this. So go here, and I'm going to look for Lambda. I'm going to create a Lambda function. And I am going to use a blueprint for Alexa for Python. So I'm going to select that. The event source type is Alexa Skills Kit. I'm going to hit next here. And I am going to name this My JAWS Skill. And then over here, I have a snippet that I'm going to put. Now, all this really is doing, let's actually, is this better? Can you guys see this in the back? All right. So this is really a very simple Lambda handler function. The first thing we are doing is we're getting the event and the context from the skill that was used to call it. And then over here, we are trying to identify what kind of request it was. There could be three kinds of requests. So when you actually launch a skill, when you say with this very specific intent, say, Alexa, ask JAWS what is Lambda. You have specified a very specific intent, and that is when you will call the intent request. And some of the other types of requests could be you just launch the request without specifying what you wanted to do. So if you just say, Alexa, open JAWS, you did not specify what exactly you wanted to do. You just said open JAWS. And in that case, the request type is launch request. And you can specify based on what kind of request the user gave you, you can segregate them and handle them separately. And in this case, we will get a very specific intent request, and we will return on intent function, which is where we are specifying what needs to be done, which is right over here. So once we have figured out what that intent is, we need to figure out what we need to do with it. So in this case, if it's service description intent, we are calling the get service description function. And the get service description is really calling this API which we've already set on API gateway, and I'll just go into that in just a little bit. And then based on that, it gets the information back, and then it creates what we call a speech output, and then it sends the speech output back as a JSON request. And that's really all that this function is doing. I am going to select a role of basic execution, just set the security, and click allow. I'll leave all the defaults, say next, and I'll create the function. So now this is the ARN that our skill was looking for. So I'm going to copy this and go back here and paste it. And account linking is how you can connect your existing, if you have a user base and you just want to connect your user base, you want the ability to connect, you want them to have the ability to connect using your user account, you can actually do that with this. But we'll just say no here. And this is the voice simulator. We can actually test our skill right now. So we will ask, actually, we can just say, what is Lambda? And keep my fingers crossed. It should come back with a response. And it does. So this on the left is really the Lambda request that was sent, and on the right is the response we got. So you can see it has some response. And we can actually play this right now.
AWS Lambda lets you run code without provisioning or managing servers. You pay only.
Pretty cool, right? Let's try one more. Let's try what is IoT and play this.
AWS IoT is a managed cloud platform that lets connected devices.
So it's really that simple. All you really did was create a quick Lambda function and an API, which, let me show you how we did that. Let's go back in here. API gateway. And I'm going to just show you one of the APIs that I had created. Let's call this. So this is the API that I had created some time back, just for ease of, just to speed it up. And all it is doing is, it has this endpoint. So if I come back here and I do the same exact request here, I will get the JSON response here. So there you go. And that's exactly the response that it's throwing to our skill. Now the beauty of Alexa is that this skill is actually now available on my Echo. So as long as I sign in to my device using my Amazon account, and I'm using the same Amazon account to log into developer.amazon, the skill is already live and available to me. Once I'm happy with that skill, I can go to the next step and publish it. It goes through a certification process, and then your skill is available to all of these users that have Alexa-enabled devices. But since we don't have an Echo with us, I want to show you this on this simulator that we have. So I'm going to ask JAWS, what is Lambda, and I should give a response back. Ask JAWS, what is Lambda?
AWS Lambda lets you run code without provisioning or.
So there you go. That's our little skill that we created. Let's jump back into our slides real quick. Now, looking at just this slide, it looks like we might be onto something. And this is really important. Look at all these billions and billions of things that will be available on the internet by 2019. And we really think voice will be a major, major part of this. Now, when we started, we didn't know if this would be something big. We just wanted to invent something, and it turns out that that's what people are looking for. What we really want to do now is take this concept and make it available to the developers. The really cool thing about future is that it doesn't exist yet. We get to build it together. And we are humble enough to know that we cannot do it together. We need the help of developers like yourselves to build the next future, the future of voice. And it's still day one at Amazon. We like to say this and we like to remind ourselves that it's still day one and we have a long way to go. Now, while the Echo and all of these other devices are not available in Japan just yet, I want to make it a point that internationalization of these products is really, really important for us. And I can't say more than that because I want to keep my job. And I just want to thank you for your time today. And I hope that this has been inspiring enough for you guys to go ahead and play around with Alexa Voice Service and Alexa Skills Kit. Thank you very much.
AWS アミット・ジョワニ様よりご講演いただきました。ありがとうございました。